Meanwhile, the next task was to extend the model. Essentially, the team created an array of virtual rocks to observe their impact on seismic velocity. Using measurements from previous lab experiments, they took multiple factors into consideration, including buoyancy, mineral composition and electromagnetism. And ultimately, they made a groundbreaking discovery. Speaking to National Geographic in July 2018, Dr. Joshua Garber from Penn State University explained how their findings differed from previous research. He said, "What we found, in contrast to previous studies, is you can't just use the main rock type in the mantle, that's called peridotite, to explain these velocities. You need something that's a little stiffer." In fact, according to the CIDR group, the only rocks capable of creating the observed velocities were those containing 1–2% diamonds. In addition to diamonds, the rocks were found to contain peridotite and trace quantities of eclogite, which is typically seen in oceanic crust. The mystery was solved. Diamonds were causing the sound waves to accelerate. Dr. Ulrich Fall, a CIDR researcher from MIT, told The Independent in 2018 that diamond is a much better conductor of sound than most other cratonic rocks. He said, "Diamond in many ways is special. The sound velocity in diamond is more than twice as fast as in the dominant mineral in the upper mantle rocks." In fact, according to Dr. Fall, diamond is the only mineral that could have caused the observed changes in seismic velocity. He told Business Insider in 2018, "We went through all the possibilities, from every angle, and this is the only one that's left as a reasonable explanation." Of course, this would mean that the Earth's cratons contain vast resources of the precious gem. To estimate how many tons of diamonds might be hidden underground, the CIDR group simply calculated the total volume of the Earth's cratonic roots and then used their estimated diamond content of 1–2% to arrive at a final figure. And the results were staggering. According to the group, the world's cratons conceal a quadrillion, or 100,000,000,000,000,000,000,000 tons of diamonds. In fact, this represents a global resource 1,000 times greater than previously thought. In a 2018 MIT statement, Dr. Fall said, "This shows that diamond is not perhaps this exotic mineral, but on the geological scale of things, it's relatively common. We can't get at them, but still, there is much more diamond there than we have ever thought before." Of course, the scientists' findings haven't convinced everyone. According to Suzanne van der Lee, a seismic expert at Northwestern University, the change in seismic velocities may have been caused by some unidentified factor. She told National Geographic in 2018, "I'm taking the conclusions, personally, with a grain of salt." Meanwhile, the research tends to corroborate our existing understanding of where and how diamonds form. Although diamonds consist of a relatively abundant chemical element, they form under exceptional circumstances and only in specific environmental conditions. Typically, their formation requires extreme pressures and temperatures such as can only be found deep below the surface of the Earth. Specifically, diamonds form in so-called diamond stability zones, at depths of approximately 90 miles. They also require a minimum temperature of 2000 degrees Fahrenheit to form. However, diamond stability zones are not ubiquitous. They're normally found underneath continental plates. In fact, diamond stability zones occupy exactly the same places where one would expect to find cratons. Furthermore, when diamonds reach the surface of the Earth, they tend to be carried by volcanic eruptions that seem to originate in cratons. The eruptions are relatively rare and occur at intervals of tens of millions of years. They carry magma to the surface, which then cools into igneous rocks known as kimberlite pipes, which carry diamonds within them. Kimberlite pipes have mostly been found at the edges of cratons. And they've specifically been discovered in South Africa, Canada, Australia and Siberia, places all well known for their diamond resources. Therefore, the CIDR group's chief claim that cratons contain large reserves of diamonds appears to be consistent with our previous understanding of where and how diamonds are forged. Furthermore, Cider geochemist Dr. Megan Duncan explained to Science News website in verse how the quantity of diamonds believed to exist in the cratons does not exceed current estimates for the total carbon on Earth. She said, "While it is a higher concentration of diamonds than we would have expected, we are not adding lots of extra carbon to the Earth's overall budget." However, the research does promise several new insights, particularly with regards to craton formation and stabilization. And this should also improve our understanding of the Earth's early geologic history. Dr. Duncan continued, "It does have some interesting implications for ancient Earth processes, like subduction, and how it may or may not have changed with time." Meanwhile, aside from their scientific value, the diamonds have enormous economic potential. Indeed, they represent one of the most valuable resources on the planet. At current market prices, a ton of diamonds is worth approximately $3,800. That means the cratons contain gems to the tune of a staggering $191 septillion, or 191,000,000,000,000,000,000,000,000,000,000,000,000,000,000. Naturally, any dollar sum with 24 zeros is hard to visualize. However, to put it into context, the total value of the world economy, as calculated by the CIA's World Factbook in 2014, is approximately $78.28 trillion US, or 78280000000000, which is a figure many leagues lower than the value of the diamonds. Of course, all this assumes that markets are static, which they aren't. In fact, mining so many gems will almost certainly have a negative impact on their value. One historical precedent is the Spanish price revolution, in which the Spanish Empire flooded European markets with vast quantities of gold plundered from the New World. Along with several other factors, the price revolution caused the value of gold to plummet. And ultimately, Spain went bankrupt 3 times during the 1500s. So should we all rush to invest in diamond mining corporations? Is a high-tech diamond rush now imminent? Will we soon all be wearing diamonds as casually as brass buttons? Apparently not, unfortunately, since the diamonds are located at depths of 90 to 150 miles, they are impossible to extract with current technology. Indeed, it is doubtful that we will ever be able to reach such depths, at least not in our lifetime. At present, the deepest that humans have ever dug is 7.6 miles, a mere fraction of the necessary 100 miles. In order to reach the diamond stability zones, we would require machinery capable of withstanding extraordinary pressures and temperatures. Still, the world is a richer place for the findings of the Cider Group. Not only do they enhance our scientific understanding of the planet, but they spark our imagination. Deep within the dark heart of the Earth, within inverted mountain ranges which support our world, a wealth of diamonds would glint and sparkle, if only light from the surface were ever to reach them.